Hello everyone, welcome to iitiansgateclasses. In this video, we are going to solve GATE 2023 questions of engineering mathematics, which were asked in computer science and information technology paper. There were total 4 questions asked in this paper, and we will solve them one by one. Starting with the first question. This question is related to the matrix and determinants. Matrix A is given, which is 1, 2, 3, 4, 4, 1, 2, 3, 3, 4, 1, 2, and 2, 3, 4, 1. Whereas matrix B is 4, 3, 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 1, 2, 3, 4, and 2, 3, 4, 1. And let determinant of A and determinant of B denotes the determinants of matrix A and determinants of matrix B respectively. Which of the following option is true? So they are given two matrices, and we are to check what is the relationship between the determinants of these two matrices. If we look into the first of all into these two matrices in detail, we can clearly see the last row is same. Second row is also same, 4, 1, 2, 3, 4, 1, 2, 3. Last row is 2, 3, 4, 1, 2, 3, 4, 1. What is about the first row? 1, 2, 3, 4, that became here third, 1, 2, 3, 4, and 4, 3, 1, 2, we became first. So basically, in matrix B, if we interchange the first row and third row, or either you interchange in B or either you interchange in A, you'll end up with the second matrix. So if I interchange in matrix A first with the third, I'll end up with the matrix B, right? So let me write down the matrix first of all. Let's say the matrix is matrix A is equal to, starting with 1, 1, 2, 3, 4, 4, 1, 2, 3, 3, 4, 1, 2, 2, 3, 4, 1. And this is matrix A. And if we interchange row 1 with row 3, then we can say that the matrix A will look like this: 3, 4, 1, 2. Then 4, 1, 2, 3 as it is. 1, 2, 3, 4 will become the third row, and then 2, 3, 4, 1. And what about this? This matrix became now matrix. This is same as our matrix B, right? 4, 3, 1, 2, 4. So first row is 3, 4, 1, 2. Look at this, 3, 4, 1, 2, right? So basically, our matrix is it became the same as that of the matrix. A and B are now same by performing this row operation in matrix. If we call that for that this particular matrix determinant is A, then in this case, for this matrix, the determinant will be minus of, I'll say, in this case, the determinant will change to negative sign. Okay, negative sign multiplied by determinant of A, okay, of the original, because this is the A dash matrix, we'll call it. Or let's say A1. We know that if we interchange two rows in a matrix, the sign of determinant changes. So that's why we are writing it like this. We say that if we interchange two rows in a matrix, sign of determinant changes. So in first case, determinant is, let's say, let's call it as a determinant of A, det A. Then in second case, I would say it will be minus of det A. Okay, and which is equal to determinant, which is equal to the determinant of B. So these two things are equal. So we can say that in this particular case, option B is correct. That is, determinant of B is equal to minus determinant of A. Coming towards the next question. This is from the maxima and minima topic. They have given us the function f of x is equal to x cubed plus 15x square minus 33x minus 36 be a real valued function, and which of the following statement is are true. And they are, the options are related to the local maxima and the local minima. Let's write the function first of all. F of x is x cubed plus 15x square minus 33x plus 36. Okay, yeah. And let's calculate f dash of x. If you differentiate this function with respect to x, you'll end up with a 3x square plus 30x minus 33 and equate it to 0. You'll end up with x square plus 10x minus 11 equal to 0. If you further solve them, you'll end up with x plus 11 and x minus 1 equal to 0. This implies x is equal to minus 11 comma x is equal to 1. So these are the two critical points in this case. So let's call it as a critical points. Now let's calculate the double derivative of the function. F double dash of x will look like as 6x plus 30. And at these critical points, let's calculate the double derivative. F double dash of 1 will be 6 times 1 plus 30, which is equal to 36, which is greater than 0. And we know that if double differentiation is greater than 0, that is nothing but your local minima point. Okay, and when you put when you calculate the f of 1, you will get the minimum value of the function. Then next one is let's calculate f double dash of minus 11. It is equal to 6 times minus 11 plus 30, which is minus 66 plus 30, which is equal to minus 36, which is less than 0. And so this is the corresponding to the corresponding point is our local maxima. So of course the given function has a local minima as well as a local maxima. So what is the question? F of x has local maxima and f of x has local minima. So option B is also correct. Option D is also correct. So they are asking us which of the following statements is oblique are true. So it is like a question where you can have multiple options which are correct. So you should choose option B and D in this case, okay, because both of them are true. Option A says f of x does not have a local maxima. That is incorrect. And option C says f of x does not have local minima. That is also incorrect. So correct option in this case is B and D. Coming towards the next question. Let A be the adjacency matrix of a graph with a vertices 1, 2, 3, 4, 5, and let lambda 1, lambda 2, lambda 3, lambda 4, and lambda 5 be the 5 eigenvalues of A. Note that these eigenvalues need not be distinct. Okay, that means they may not be different. Some of them can be same. The value of lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 plus lambda 5 is. Okay, first of all, whenever you have this kind of graph, you should try to convert it into the graph. So first step is convert this unidirected graph, you can say, into a adjacency matrix, because they are talking about the adjacency matrix. And once you have the adjacency matrix, then you can calculate the eigenvalues, and then the corresponding sum of eigenvalues you can do. So the best way to calculate the adjacency matrix is we have 5 different points. So it will have 5 rows and 5 columns. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So 1 is adjacent to 2 only, and at all other places it is not adjacent to any other number, right? It is not adjacent to 3, 4, 5. So that's why 0, 0. 2 is adjacent to 1, 2 is adjacent to 3, and 2 is adjacent to 4. So it is 1 here, 1 here, and 1 here. It is not adjacent to 2 and 5. 3 is adjacent to 2, 3, and 5. So it will be 1, 1, and 1. The rest of the places it is 0, 0. 4 is adjacent to 2, 4, and 5. So it will be 1, 1, and 1. The rest of the places it is 0, 0. 5 is adjacent to 3 and 4. So it will be 1, 1 here, and rest of the places it is 0, 0, 0. So this is now the adjacency matrix of a given unidirected graph. Now, the question they are asking us to find the sum of the eigenvalues. So all this is a 5 cross 5 matrix, and the number of eigenvalues in this case is 5. So sum of all the eigenvalues is what they are asking. We know that sum of the eigenvalues, or let's say here we can write sum of the eigenvalues is equal to trace of a matrix. Okay, is equal to trace. This is neither a upper triangular, lower triangular, not a diagonal matrix. So we cannot say that they are along the principal diagonal. So if you go on calculating the eigenvalues, it will take some time. But using the property, sum of eigenvalues is equal to trace of a matrix. We can easily get the summation. Okay, trace means what? Sum of elements of principal diagonal. Calculating the eigenvalues and then making sum of it will be a very lengthy process. However, if you know this property that sum of eigenvalues is equal to trace of a matrix, you can easily get the answer. So trace in this case is 1 plus 1. That is, first is 0 plus 0 plus 1 plus 1 plus 0. That is equal to 2. Hence the answer is 2 in this case. Okay, they have not given option. We are supposed to type it. Yeah, it's completely based on preparing the adjacency matrix and then using the rule that sum of eigenvalues is equal to trace of a matrix. The last question is from the integral calculus, multiple integration topic. The value of definite integral, integration minus 3 to 3, minus 2 to 2, minus 1 to 1, 4x square y minus z cube, dz dy dx is. So let's try to solve it. You can clearly see here that these are the limits of z, these are limits of y, and these are limits of x, because that is the order of integration which is given. So we have to integrate first with respect to z. So we can say that integration integration x is equal to, in just a minute, integration x is equal to minus 3 to 3 integration y is equal to minus 2 to 2, and integration of v given function with respect to z is 4x square y as it is, integration of 1 is z minus z raised to the power 4 by 4, and you'll put the limit minus 1 to 1 dy dx. Whenever you put 1 here, what will happen? this part will become 4x square y into 1 minus 4x square y into minus 1. So it will become 8x square y. However, the second part will become 0 because it's a 1 by 4 minus 1 by 4. It will become 0. And integral will become very simple now. X is equal to minus 3 to plus 3. And y is equal to minus 2 to 2. And you will have 8 x square y dy dx. At this point, you should understand that 8x square, whenever you take the integration with respect to y, 8x square term will be constant. And integration of y is y square by 2. Y is basically an odd function. And we have odd function with opposite limits. The value of integration is 0. Hence, at this stage itself, you can say the answer is 0. If not, you can, if to help you understand, x is equal to minus 3 to 3. 8x square as it is, integration of y is y square by 2, putting the limit minus 2 to plus 2 dx. When you put here 2, it will become 2 minus 2, it will become 0. So 0 multiplied by anything becomes 0. Hence, the answer is 0. Okay. So the correct answer in this case is 0. Yeah, that's all from this paper. Thank you all for watching this video.